Okay, this is part two of the center wheel assembly. I have the shaft cut down to the proper length here of 85 millimeters. Uh, in part one, you seen I used the full length 300 millimeter length shaft, but you should really use the 85 millimeter pre-cut to put the parts onto. I've just started pushing the pins for the ratchet pawls through to the back there, because the pawls go on the side we're looking at here now, and I'm putting two washers on the center where the weight drum will go, because we want the weight drum to be just that little bit further away from the gear to give space for the ratchet pawls to sit on their pins without being jammed between the drum and the gear. So one single washer will go on where the ratchet pawls are going onto, as we'll see, onto the three pins, and then put the ratchet pawls on in the required direction, which if you take note from the video, you'll know what that is. They have to be on in certain directions so that the ratchet drum will slip one way to allow winding, and then when the weight takes tension, it drives the center wheel by the virtue of the ratchet on the back of the drum catching the pawls when they're in a clockwise direction looking from the front. So we've the three pawls in place now, and the drum with the ratchet at the back of it will sit in between them. Now, as I said, because it's sitting on two washers, it won't pinch the ratchet pawls against the gear, which allows for more free winding, less friction. Now you can see the way the mechanism works there. They slip over the pawls one way but catches when it goes the other way. And there's three of them, so that the top one usually catches because the way the gravity works on the pawls. Now we'll just put this into the vise. Now I've already, since the last video, pre-fitted the 7-tooth pinion here. I didn't glue it though, so I'm just going to pull it back, put a bit of epoxy on. Because we measured in the part one video the distance from the end of the shaft, as we look at it here, to the end of the front of the spacer, which is glued to the wheel, as 29 millimeters. That'll be the fixed distance, so we can now glue the 7-tooth pinion to the spacer without having to worry too much about glue getting onto the shaft. Because once this is set anyway, the shaft will never be moving inside the gear again anyway. It will always turn with the gear, because the minute hand will be on the front of this shaft, just outside the front frame of the clock on the dial, which measures minutes. Because this wheel, as we have mentioned in the first video, like the center wheel of any clock, turns in 1 hour, and gear and the shaft that turns in 1 hour is the one that carries the minute hand, because the minute hand takes 1 hour to go around the clock dial. Now we mix the small amount of epoxy required so we can glue the 7-tooth pinion to the spacer. Now this 7-tooth pinion, by virtue that it spins once an hour, will be turning the 84-tooth 12-hour wheel. So because the 7-tooth one takes 1 hour to turn, it will take 12 hours to turn the 84-tooth one. And the shaft for that 84-tooth one will carry the hours hand, because it takes 12 hours to do one full rotation on the clock. So we just move the 7-tooth pinion back into place. Now we need to remove, just make sure there's no excess glue gone into the channels or the grooves of the 7-tooth pinion, so we wipe it off with a bit of cloth. You can see why the spacer has to be smaller, so much smaller than the 7-tooth pinion, because the outer diameter of the small spacer can't overlap the, what would we call, the valleys of the 7-tooth gear. Otherwise it will interfere with the tips of the teeth of the 84-tooth gear, which the 7-tooth one will be driving to give us our 12 hours as mentioned earlier on. So now we put the outer spacer on. This is the one that keeps the right distance from the frame. this doesn't get glued to anything, it just goes up more or less against the 7-tooth pinion. And set it into the frame there, we're in the where it's going. Now we're just going to put another shaft in the vise here because the hole in this spacer is very tight and I don't want to force it onto the shaft or arbor on the center wheel assembly for fear of bending it. So we'll just use a smaller piece here just to loosen up the spacer, the hole in the spacer here. They're fairly tight, but it's doable. You keep swapping them around rather than forcing it through in one go, as we say, because you'll break out the back layers of wood as it comes through, unless you keep swapping around and gently easing it through. Then eventually, once it goes through, it's easy enough then to push it onto the other shaft, as we'll be seeing here. So we reposition the center wheel assembly shaft, or arbor as they're correctly called, into the vise, and we'll put the front spacer into position again. And I think it ends up just more or less being against the 7-tooth pinion I've shown. And then the whole assembly should fit nicely between the two frames, front and rear frame and the clock, without any jamming. So at the back here, you can see a washer. I think I usually put 2 washers there for this one. At the back, and then 1 washer at the front. Put the front plate on now and see how it runs in the frame of the clock. So you put the front frame into position the right way if I look at what I'm at here. And just guide the center wheel arbor through its hole. It comes through about 20 mil or around that, so obviously we can mount the minute hand onto the shaft. This clock design has 3 separate faces, 1 for hours, 1 for minutes, and 1 for seconds. So there's the center wheel spinning in the frame. Looks free enough. Now we'll just clip in the fixing clips, keep everything in place. Now I'm just showing you a little bit of play from front to back here. That's what you want. You don't want it wedged between the 2 frames, or there will be friction and stop it from turning. Now I think we will probably be getting the second wheel here. So you have the center wheel there, which is in the clock frame, which is the wheel which drives everything. And then this drives the 8-tooth pinion on the back of the 60-tooth pinion, which forms the second wheel. The second wheel here goes in beside it, beside the center wheel. Now we can get a look maybe at the center wheel. Just before it goes in. So it looks like it does in the drawings. You can see the parts involved in it. So it goes together. It's not actually glued here. It's only dry fitted on the shaft that it's on its arbor. Just to test. You don't want to glue anything together till you make sure this gear runs freely with the previous one. Because sometimes the pinion might be sticky and you might either have to sand it or cut out a new one marginally smaller. But usually from the laser it's okay. But if you glue everything together, you'd have to remake the entire assembly. So when you put this second wheel together, you just glue it together and get the wobble out of it exactly like we did for the center wheel in part 1 of the video. So we put it in place and obviously it turns okay there, but to see a proper test, we need to put the front plate on. So we put washers on. There's already a washer on the back there. Put a washer on the front of the second wheel now. Put the front plate on. Each time you add another gear assembly, it'll be a bit more tricky to get the front plate on because now you have two uh, arbors to line up with their holes, and when the whole gear drive mechanism is put together, there'll be four plus the pin for the hang the pendulum out as well, so there'll be five shafts altogether. Now you can see there's wobble in the second wheel, but that doesn't really matter here because it's not glued into place on the on its spacer, etc. As said already. So when you glue it, you just follow the same sort of procedure as seen in part one of the center wheel assembly on reducing the wobble. Now there's a bit too much play there, so I'll have to move the back spacer back towards the rear frame here. So these spacers you can move back and forward to get them just right between the frames. So we're just right here now, actually a bit too tight, so we're just going to have to push them. If you gently squeeze the frame, you can just push them back a bit and then release the frame and without breaking it, of course, and there we go. As I said, there's a bit of wobble in the second wheel, but we haven't glued it up yet, so we haven't went through the wobble removing procedure just yet. So when we do, we remove that. So the second wheel and the escape wheel and the 12-hour wheel all use the same sort of procedure to put them together and remove their wobble, as was seen in part one of the center wheel video. So, and now I'm just turning the ratchet mechanism in reverse. That's when you're winding it, that's the way it would turn to allow it to wind up the string, and then when you release the weight, it drives it the other way. So going clockwise, it drives the mechanism. Going anti-clockwise allows you to wind it without having to turn anything in the mechanism. As you can see it there, the way it works, very simple really. So when the escape wheel is in, one turn of the center wheel will actually turn the escape wheel 60 times. It turns one turn of the center wheel, turns the second wheel 7.5 times with the gear ratio in this setup. And that's it for this video.